Here we are in section 2.2 with the last of the problems, 29 through 38. This says solve for the specified variable. So that means in this one, for b, we're trying to get b by itself. So that's what we're doing. We're rearranging these formulas using our incredible abilities to manipulate equations. So now we want to get b by itself. Well, if you can see over here, these two are timesing together, but as far as being attached to b, they are attached with a plus sign, and they're positive. So we are going to subtract mx, that number that's glued together with multiplication, subtract mx from this side. We now have b by itself. Those guys are gone. So this is y minus mx. And we can't combine them. They're not like terms. So we are done. That is what that answer looks like. Kind of interesting that it looks like a problem in and of itself. Let's do another one. Number 30. Here we're trying to get m by itself. Solve for m. So let's add 7, just like we normally would. Add 7, add 7. The only difference between this and previous problems is that r plus 7, we can't make it a number. It's just r plus 7. And then we're going to get rid of this 5. So divide by 5, divide by 5. Those go away. And m is by itself equaling r plus 7 over 5. Doesn't look like much of an answer, but that is the formula where m is now by itself. Number 31. We're trying to get h by itself. So we look at all the other numbers, and they're all multiplied together here. So the only way to get h by itself is to divide off all of these other numbers, the 2, the pi, and the r. Let's do that on this side too. Divide by 2 pi r. These guys all go away. So h is left by itself as a over 2 pi r. Good. Number 32. We're going to try to get b by itself. So here's the b right here. So we have to get rid of this 1/2, and we have to get rid of that h. Let me see. How do we get rid of a 1/2? If we divide off by 1/2, that's the same as timesing by 2 over 1. So we have 2a equals, that guy's gone, bh. So now we got to get rid of that h. It is multiplied, so we divide by h, and we get b equals 2a over h. And that's good. Now you should know we could have divided by the 1/2 and the h at the same time and had an 1/2 h right here. And then the 1/2, when you divide by 1/2, would have flipped and multiplied and given us the 2 anyway. But that's kind of the cleaner way to do it. Number 33. We're trying to get m by itself. So let's get rid of this whole kit and caboodle here first, the addition and subtraction. So we add 8qt to both sides. So we're left with 3m equals 14 plus 8qt. Divide by 3, divide by 3. Our m is now by itself. And we have m is equal to this 14 plus 8qt. We can't combine those. They're not like terms. Divided by 3, and we're done. That formula. It doesn't look like an answer, but it's there. We're now going to do the next one for r, trying to get r by itself. And all of these guys are timesing the r, so just divide them off. You should start to feel a little powerful about now. You're like, I want that 3pq gone, and so you get rid of it. And we're left with r equals 19 over 3pq. Number 35. We want to get f by itself. Now, let me see. F, by order of operations, this is first subtracting the 32, and then it's timesing by 5/9. So if I'm going to undo those, I first want to get rid of that and divide by 5/9, which is the same as timesing by 9/5. Let's get rid of that guy first. So we get 9/5 c equals f minus 32. Yeah, because the parentheses now are not necessary. So now to get f by itself, we add 32, and look at this. We get f equals 9/5 c plus 32. You should recognize that particular formula right there as the formula that converts Celsius to Fahrenheit, and this is the formula that converts Fahrenheit to Celsius. This is how they get those two formulas. They're just solving for F to get this one, and then you solve for C, and you'll get that one. That's kind of a cool little thing. And number 36. We want to get H by itself, so we've got to divide all of those guys, get them off. Now, if we divide by a 1/3, I think I'll take care of him first. Times by 3 times by 3. That way the fractions are kind of not in the denominator. So we get 3v equals pi r squared h. Divide by pi r squared. Divide by pi r squared. Those guys are gone, and h is now left by itself. So we get h equals 3v over pi r squared. Excellent. Now, on number 37 and number 38, these are preparation problems, so you don't have to get the right answer here, but I'll show you how this was done so that you can see what's going on. Here you have x plus blah, 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 whatever that thing is, 9 plus blah, 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 whatever that thing is, but you notice they're exactly the same. If we go back to what it is to have a balance here, and we have an x block, and then we have a blob, and we have a 9 block over here, and we have a blob. Can we tell what x has to be to make this thing right here true? Well, yeah, x has to be 9 for this to balance. This guy has to weigh exactly the same amount as that guy. And we do that by saying, hey, that guy, we could just subtract off the blah, 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 blah. Subtract off the blah. X equals a 9. Now, that was a little bit silly to have squiggles in the middle of an equation, but it brings up a good point. Here we have a 9y, here we have a 9y. We can add, subtract, multiply, or divide anything we want to both sides. Why not do a 9y? And he's gone. We just subtracted 9y from both sides. Same thing, we can subtract the 10p from both sides. And we get 5x equals 15, which that's a nice one to solve. X equals 3. Good, you'll be well prepared to learn the next section.